So, you know, when I look at a new code base for refactoring, the first thing is to understand how it all fits together. It's like solving a puzzle without knowing what the picture looks like.
Right? And that can be daunting if the documentation isn't up to date.
Exactly. And then there's always that one part of the code that no one wants to touch because they're afraid something might break. Remember last year when we had to fix that old inventory system? No one knew how half of it worked.
Yeah, that was tricky. We ended up spending weeks just trying to figure out the dependencies.
That's why it's crucial to map everything out first. You start with the high-level architecture and work your way down into the modules and functions. It's like peeling an onion layer by layer.
Makes sense. But how do you deal with the parts that are intertwined?
Well, you have to isolate them as much as possible. Create tests around those pieces so you can see what breaks when you change something. It's tedious but necessary. Also, try not to refactor too much at once. Small incremental changes are easier to manage.
Incremental changes, got it. What about performance bottlenecks while refactoring?
Good question. Sometimes when you clean up code or add abstractions, you might inadvertently introduce inefficiencies. The key here is profiling before and after changes. If you notice any drops in performance, revert back and find another approach.
Profiling sounds important then.
Absolutely critical. Another tip is to keep your version control commits small and focused on specific aspects of the code. This way, if something goes wrong, it's easier to pinpoint where things started failing.
Small commits definitely help trace issues more easily.
And don't forget about communicating with the rest of the team. Let them know what sections of the code you're planning to touch so they aren't surprised by unexpected behavior in their parts of the project.
Communication is key, especially in big teams.
Oh yeah, it saves a lot of headaches down the line. Now, remember that time we thought we fixed a bug only to cause 3 more? Speaking of which, identifying critical sections of legacy code is crucial. You need to focus your testing efforts where it matters most.
Definitely. How do you determine what's critical?
Start by looking at areas that handle core business logic or have direct impact on users. For example, payment processing or user authentication should always be top priority.
Those are definitely high-risk areas.
Exactly. Also, consider the parts of the code base that haven't been touched in a long time. They might contain hidden bugs or outdated practices that could affect stability.
Old untouched code can be problematic indeed.
And don't overlook error handling and logging mechanisms. If these are weak, you'll spend a lot of time chasing down issues that could have been caught early.
Error handling is often overlooked, but so important.
Absolutely. Once you've identified these critical sections, prioritize writing comprehensive unit tests and integration tests to cover all edge cases. It's better to catch problems now rather than having them surface later when they're harder to fix.
Edge cases can really trip you up if you're not careful.
They sure can. Plus, make sure you involve stakeholders in reviewing these test plans. Their input can highlight scenarios you might otherwise miss.
Stakeholder feedback is invaluable for catching those hidden risks.
Agreed. And remember, continuous integration tools can automate a lot of this process, making it easier to spot regressions as you refactor. So set up automated builds and regular test runs right from the start. Absolutely. Setting up CI is a must. But let's talk about creating a comprehensive test suite to cover all those legacy functionalities.
That sounds like quite a task.
It can be, but it's essential for maintaining stability as you refactor. Start by mapping out all the functional requirements and ensure each one has corresponding tests.
Mapping out requirements helps a lot.
Definitely. Use both unit tests and integration tests to cover different layers of functionality. Unit tests will help you validate individual components, while integration tests will verify that everything works well together.
Combining unit and integration tests makes sense.
And don't forget about regression testing. As you make changes, run these tests frequently to catch any unintended consequences early on.
Frequent regression testing is key to avoiding surprises.
Exactly. Also, consider using property-based testing for complex logic. It can generate many test cases automatically based on the properties of your functions, which can uncover edge cases you might have missed otherwise.
Property-based testing seems powerful for thorough validation.
It is. Plus, mock objects are great for isolating dependencies during testing. This way, you can focus on the behavior of the component itself without worrying about external systems failing.
Mocking dependencies keeps the tests cleaner and more reliable.
Indeed. And document your test strategy clearly so anyone joining the project understands how the testing framework is structured and why certain approaches were chosen.
Clear documentation ensures everyone is on the same page.
Precisely. With a robust test suite in place, you can confidently make changes knowing that critical functionalities remain intact. And speaking of confidence, using version control systems effectively is crucial during the refactoring process.
Definitely. How do you recommend managing branches and commits?
First, keep your commit messages clear and descriptive. Each commit should reflect a single logical change so others can easily understand what was done and why.
Clear commit messages are very helpful.
Absolutely. Use feature branches for larger changes. This allows you to work on modifications without affecting the main branch until everything is tested and ready to merge.
Feature branches help isolate changes nicely.
Exactly. Regularly pull from the main branch into your feature branch to avoid big merge conflicts later. It's also good practice to push your changes frequently to create a detailed history and allow others to review your work incrementally.
Frequent pushes make merging smoother.
True. Consider using pull requests or code reviews before merging significant changes. This not only catches potential issues early, but also promotes knowledge sharing among team members.
Code reviews are great for catching issues and learning from each other.
Absolutely. Lastly, use tags or labels to mark important milestones, like releases or major updates. This makes it easy to track progress and roll back if necessary.
Tagging milestones helps with tracking and rollback options.
That's right. Effective use of version control ensures that you can manage changes systematically without disrupting the overall project flow.